All right, welcome. Today, we're talking about something huge happening in data analysis, a massive leap beyond just having better tools. We're stepping into a world where data science can, well, kind of perform itself. So, what does it actually mean? Let's dive in. So, let's just start with this one big question. What if your data could analyze itself? And I'm not just talking about running a pre-written script. I mean, what if it could actually understand a business problem, dig through the data, come up with its own hypotheses, and then report back what it found, all on its own? That's the world we're stepping into. This is where we get to the core concept, Agentic Data Science. At its heart, it's all about using autonomous AI agents. Now, these aren't just your standard models. We're talking about systems that can look at a goal, figure out a plan of attack, use tools like a coding environment, and basically run an entire data science project from beginning to end. To really wrap our heads around this, we need to understand just how fundamental a change this is. It's a true paradigm shift. We're moving from something static and human-driven to something way more dynamic and agent-driven. Okay, so think about it this way. In the old school model, a human is pulling all the strings. Every step is pretty rigid, and the models are just passively waiting for us to tell them what to do. But in the agentic world, the agent is in the driver's seat. It's actively thinking with the data, figuring things out as it goes. For instance, a static system might spit out a fraud report once a month. An agentic system could be watching transactions live, spotting new fraud patterns the second they appear, and even suggesting new rules to stop them. Honestly, it's like the difference between just using a calculator versus having a smart colleague to bounce ideas off of. And this visual here, it just nails the difference. So you see on the left, that's the traditional way. A straight, linear conveyor belt where the human is totally in charge. But then look at the right. That's the agentic world. The agent is right there in the middle of this dynamic cycle, constantly perceiving, planning, and acting in this continuous feedback loop. All right, so this begs a pretty big question. If these agents are so autonomous, how on earth do they think their way through a really complex data problem? And that brings us to what's called their cognitive architectures. So what's really going on under the hood here? It's not magic, right? It all comes down to the cognitive framework that's guiding its logic. And the way these frameworks have evolved is pretty fascinating. So the first attempts at this used something called chain of thought. It's exactly what it sounds like, a straight line of thinking. Step 1 leads to step 2, leads to step 3, and here's the kicker. If just one of those steps is off, the whole thing just collapses. It's incredibly brittle, like a line of code that crashes an entire program if there's one tiny bug. But that's where a much smarter model comes into play, graph of thoughts, or GOT. Instead of that one fragile chain, this lets the agent explore a whole bunch of different lines of reasoning at the same time. It can check out different paths, merge the good ideas, and this is the genius part. It can hit a dead end, backtrack, and try a different path without having to scrap everything and start from scratch. Okay, so look closely at this diagram. You can actually see how much more resilient this is. Notice how all these thoughts can branch out. If one path, like thought B1, doesn't work out, no big deal, the agent just backs up and explores another one. Then it can pull together the best ideas and refine them. This is so much closer to how a real person, a real researcher actually thinks. You try things, you hit a wall, you back up, you try something else. Okay, but all this clever thinking needs a solid structure to run on. It needs a skeleton, so to speak. So let's talk about the orchestration frameworks that act as that very skeleton for the agent. There are two big names you got to know here. LangChain and its newer, more powerful sibling, LangGraph. If you look at the left, you'll see the original LangChain works in a straight line. It's stateless, which is just a fancy way of saying it has no memory of what happened in the previous step. In contrast, LangGraph on the right works in a loop, and crucially, it has a centralized state. In plain English, that means it has a memory. So here's the bottom line. LangChain is stateless, so when it messes up, it just stops. Game over. But LangGraph, because it has that memory, can go in loops, and that ability to try something, check its own work, and then fix its own mistakes, that is the absolute game changer for getting true autonomy. All right, so we have a smart agent and a solid skeleton, but that's still not the whole story. For this thing to actually work reliably out in the wild, it needs a whole nervous system, all the infrastructure that keeps it running smoothly. The first piece of that system is the AI gateway. Think of it like an incredibly smart traffic cop for AI requests. The agent has a task, and the gateway figures out exactly which large language model is the best fit for that specific job. It also handles stuff like caching to speed things up and bring down costs, which is, pretty critical for any real-world application. So that gateway sends the request out to the model providers. This is where the real brain power comes from. And what's cool is the flexibility here. You can tap into the huge foundation models from places like OpenAI or Anthropic for the heavy lifting, but you could also switch to a local model if you're dealing with sensitive data or just want to keep costs down. One of the biggest headaches with AI has always been the black box problem, right? Not really knowing why it did what it did. Well, that's exactly what an observability platform like the popular tool LangSmith is for. It lets you trace every single step the agent takes, logging all its inputs, its outputs, how fast it was, everything. For anyone actually building these systems, being able to do this isn't a nice to have, it's an absolute must. So if we look back at our diagram, you can see how this whole nervous system clicks together. The agent, which is built on something like LangGraph, sends its requests through the AI gateway. The gateway sends them to the right model. And the whole time, the observability platform is watching everything, letting you debug and evaluate. It all works together to create a system that's not just smart, but also robust and reliable. Okay, so we've covered a lot of ground here. The paradigm shifts, the thinking process, the frameworks, and the infrastructure. Let's take one last step back and see how this all fits together in the big picture. This is the whole shebang. Everything we've talked about, all in one place. You can see the entire data science workflow, from figuring out the business problem right through to the final report, is now handled by this autonomous agent. And it's all powered by those flexible cognitive architectures and that robust infrastructure we just went over. This is the complete system. Okay, so this leaves us with a huge and maybe slightly scary question, especially for those of you who are studying this stuff and getting ready to jump into this field. As these agents get more and more autonomous, what's our job now? What's the role of the human data scientist? Maybe our job shifts from being the hands-on analyst to being the architect, the strategist, the one who designs and oversees these incredibly powerful agentic systems. Definitely something to think about.